Welcome, students. I know that I've talked to a couple of students after school the other day, and some of the problems on the worksheet 61B that you really can't solve by graphing. And so I think there may be three of them on the worksheet, maybe three or four, and I'm going to go over the last two. I think it's 10 and 12 that I haven't covered yet. So we're going to do those right now and hopefully answer some of the questions that you've had. And there's some things that I knew there were some problems on here that you couldn't do, and I really wanted you to do this worksheet first, so when we took notes about solving linear systems, some of these exceptions and problems, difficulties of doing these problems, we could talk about. So first of all, we're going to graph these two equations, A and B, and I'm just going to quickly do the algebra for this one. I know the x term, it's a negative 2x, so I'm going to add 2x to each side. It'll be gone on the left side, it'll move over to the right and change signs, and then I'm going to divide through by 3, and then 3 into 21 will give me a 7. Now for line B, equation B, I've got y equals, I know the negative 4x will add to each side and give me a positive 4. Now when I take 4 and divide it by 6, that will simplify to 2 over 3. So that'll be 2 over 3x. And now I'm going to take 6, divide it into a negative 12, and I'll get a negative 2. So those are the two equations I need to graph. So let's graph equation A. So I start at a positive 7 on the y-axis, and I go up 2 over 3. Then I can't go up anymore, so I'm going to go down 2, back 3, down 2, back 3, down 2, back 3, and so forth. I'll go ahead and graph that line now. Right there for one point, right there for the other one. So there is the graph, the line. Now let's go ahead and do B. So I start at a negative 2, which is way down here, and I go up 2 over 3. These two lines have the same slope, up 2 over 3. Mark that, very good. Up 2 over 3. Now I'm going to go backwards, down 2, back 3, down 2 to the left 3, down 2 to the left 3. So there's all my solutions, and now we'll go ahead and graph the line. And I think you can see that there's a problem here, isn't there? And you can look, and if you know a little bit about geometry, you'll realize that these lines are parallel lines. Parallel lines have the same slope. Parallel lines, they never intersect. So what that means is parallel lines, if you have a system of equations that actually have the same slope, they never intersect, so there's no solution. So here we graph line A and we graph line B, and you can see that they're parallel. They go on for eternity each way, and they will never intersect, so there's no solution. So that's one of the things that you are supposed to learn from this worksheet, that yeah, we can have a linear system, but sometimes there's no solution. So let me go on to the next equation. So this is problem number 12. So let's go ahead and do this one. Let's put this equation in slope-intercept form. I've got y equals, this is a positive 3x, so I'll subtract 3x from each side, so it would be a negative 3x over here. And then when I divide a negative 3 by this negative 4, it'll make it a positive 3 over 4x. And then a negative 4 into a negative 28 will give me a positive 7. That's equation A. Now let's do B. I'll subtract 1x from each side. and then divide it by 2, so that will be negative 1x, 1 over 2 times x, then 2 into 12 would be a positive 6. So let's go ahead and graph this one. So let's do line A first. So I start at 7 again. Here I go up 3 over 4. Now I want to count it backwards by going down 3, back 4, down 3, back 4. So those are all the ordered pair for that equation that I can find on the coordinate plane. So let's go ahead and graph this line. So there's line A. Now let's graph B. Let's see what happens. Now this is a negative slope. I start at 6. I go down 1 to the right 2. This is a negative 1. This is a positive 2. So down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Just keep counting. Now I'm going to go up 1 to the right 2. Now you can see that there's a problem, don't you? It's not going to intersect on a nice corner where 4 squares meet in the center, is it? So what are we going to do? Well, let's just graph it. Let's just take a closer look at it here. So let me go ahead and zoom in and we'll talk about this. So you can see that this somewhere is up above 6 somewhere, and then it's over here at a negative, not quite a negative 1, but you can see that it's going to be some type of a fraction or a rational number. We don't know what that is. So there's got to be a better way to solve some of these equations than graphing, because when it's out here, that solution's out here in the middle of a square somewhere. We don't know what that is. So what we've got to do is, there's another way to solve these that we're going to learn a little bit later. And so when you come across a graph like this, just write down that there's a rational solution. So I have gone ahead and I have figured this out already, and the solution to this is a negative 4 over 5 and 32 over 5. It's negative 4/5, so that's 4/5 right there. And then how far this goes up this way is 32 over 5, or 6 2/5. So that's where that ordered pair actually is. So this is the end of this video. If you have any other questions, send me an email or leave a comment on YouTube and I'll gladly respond. Thanks and have a good afternoon, and I appreciate you tuning in.